everyone, and welcome back to the Information Bottleneck podcast. And today we are going to talk about how to make research in this agentic area. We'll talk about research, we'll talk about related topics that are related to it. And for that, we have Dimitris Papailiopoulos. Hey, Dimitris.
Papailiopoulos, very close.
Papailiopoulos. Almost. Hey, Dimitris, thank you for coming.
Yes, thank you so much. Thank you so much for inviting me. Maybe just a brief intro about myself. I'm a researcher. I'm Microsoft Research in AI Frontiers Lab, and also a professor at the University of Wisconsin. And I'm excited to be here today with you.
We're also very excited. So let's start about research and how you think it works, because the field, the both like programming and research has changed by a lot in the recent months and years, and basically we are doing kind of like different type of rules compared to what we have done a year or 2 years ago. So how do you see it? Like what we actually can take and what you are suggesting us to do?
Yeah, I guess I don't know if I'm in a position to suggest how to do research, but I can tell you a little bit how the arrival of agents has changed the way that I do research. And I think sort of like the way that I think about research at the higher abstraction level is that you start with a question and you pose some hypothesis, let's say, and then you need to set up the experiment and do a lot of technical work to set up the type of experiment that would validate your hypothesis, that will create data to support or disprove the hypothesis that you have. And that was the main technical work required to get to an answer at the end. And the answer would be whether your hypothesis is true or not. And that technical work was basically for the longest period of time what you would train researchers. Like the way that I would train students is basically, I would come up with an idea in a particular field and I'd be like, I think this is true. I think we should try to use this algorithm or play with this aspect of the model or whatever and see what happens. And then the student would go away for a week or two and come back with, with results or like why things did not work or why things did work and kind of like, take it from there. And so there was a point, I think it was February. It was a Sunday morning where I saw a blog post somewhere about someone training like a LoRa adapter that was only 13 parameters on top of GSM-8K, on top of a Quen model, and tuning only those 13 parameters was basically able to reach, I don't know, something like 80-90% on GSM-8K, something very high, let's say. And I was very surprised by that. And I thought it can't just be the model, probably is also about the data set. So the data, so GSM-8K, just a quick intro, is a high school type of math benchmark. And the questions are very simple. So it's I'm actually, I don't even know if it's high school. It's the kind of question that sounds like Mary has 6 eggs, gives 2 to George, gives 1 to Elizabeth. How many eggs is Mary left with, right? So it's basically a very in-your-face algorithmic kind of a question. And it felt to me that probably maybe even a symbolic type of a solver can do very well, right? So this is the kind of question that would typically be in the background of my head for a long time, and I would never scratch it because it feels a little silly, and I didn't, I would not typically want to waste human hours on that. But now, we have agents, and that was my first exposure where I'm like, let me see if Claude Code or Codex can actually do this. So I recorded a very long message of like, what the problem is, what I think we could try, what perhaps are reasonable or unreasonable approaches, what the constraints are, which is I did not want to use any language model. I really want to see if a symbolic agent, expert type of a system with a lot of if-then else's could get some non-trivial accuracy on GSM-8K. And so I gave the same sort of prompt to both Codex and Claude Code. I went on my Sunday morning and I came back evening the same day, and I came back to a non-trivial result. Both agents arrived to something that was like, I don't know, 10 to 15% accuracy on GSM-8K, which sounds very low, but in fact, Llama 1.7b had 11% on GSM-8K, and it's an actual large language model. And they came back with an answer that, basically you can't go to like 90%, but you can do something non-trivial. And was this a paper-worthy result? Certainly not. I would actually claim this is pretty lame, but it sort of was the first contact, if you will, with the world of agents, which kind of like showed me that basically the distance between a question and an answer has now completely collapsed. And what I mean by that is, again, as I said before, there's sort of like, you start with your question and then you want to arrive at an answer. And the path to that answer goes through a lot of technical work, setting up an experiment or, a mental framework or a mathematical framework for analyzing whatever hypothesis you have. And now all that work has been completely outsourced to Claude Code and Codex. And that was very surprising to me. And in fact, after that Sunday morning, for a couple of days, I had major intellectual dread. Basically, what does it mean? This just seemed completely insane to me, because effectively what I was doing is just iterating the scientific method, setting up your hypothesis, running the experiments, and seeing if it's true or not. And there was zero human involvement in the technical work. And I was left hanging with the question of what is left there for us. And that dread actually lasted for only a couple of days, because I soon realized that, we are now somehow in what I would call the golden age of asking questions, which is basically the, to a large extent, the technical groundwork can actually be done without any human effort. And that's just incredible if you think about it. We can spend a lot more time asking bigger questions and doing a lot more of what I would call high temperature research, which is research that effectively, somehow I feel now much more brave in crossing domain boundaries, and I feel much more brave scratching research itches that I would typically not even think of working on. While also going much deeper in these questions. And the caveat to all that is that because you're crossing a lot more in domains that you're not very comfortable, the chance of fooling yourself increases as well. And the requirement to act as a much stronger verifier is sort of like perhaps the most important thing right now. But then this kind of brings me back to what does it mean for training students? And I think that the aspects of a good researcher, or I should say them, like now in the age of agents, two of the most important traits of a researcher are taste, asking the right questions and asking things that perhaps are important and people will care about and will in some way be impactful, but also have the ability to act as a very strong verifier of whatever comes back from, whatever the agent gives you. And taste and verification, or the ability to act as a good verifier, the way that we know how to build this is by doing all the hard technical groundwork. And now in the absence of that, it's a little curious and interesting to kind of like think a little bit about what would be a good replacement, if you will, process by which you can train junior researchers and PhD students and whatnot. But I feel, sort of like, post that, first exposure to agents, I feel the effect on my own research is that I now, I'm in much closer contact to artifacts that are created using code, which I was much further away from code as a professor and, as a sort of like mentor to students. Again, because, this is typically work that is done or is used as training surface. But now I feel that I've been doing the most creative, if you will, work of perhaps my entire career, and I feel in many ways the findings that I've had in my research the past 2-3 months are by far the most significant things that I feel I've done in the past few years, and this is absolutely attributable to the fact that we have agents that now can effectively multiply the speed by which you go from question to answer.
And do you think it's like a temporal situation? Do you think like models will be at the end like perfect in verification and basically they don't need us anymore, because like you said now, right? Like I have a question, like the model can answer it like really quickly, but I still need to verify it. I still need to ask the right questions. But do you think this is a temporal situation, and like these problems, if you want, will go away?
Yeah, that's a good question. I think in terms of the model's ability to verify, I would argue that they are already reasonably good. I think they will get better to the extent that they will become perfect. I think depends on the domain, meaning that like you can always have artifacts that are unit testable somehow. And to the extent that this is possible, and you can create unit tests and you can have models sort of like, run them and whatnot. I think it is very likely that we will arrive at a future not far away from today, that the capabilities and the ability for a model to verify its own trajectory and its own artifacts will be much higher. And it is already really good. And there are sort of shortcuts to that. For example, typically what I do is I use one agent to kind of create the code base and the experimental setup and whatnot, run the full thing, and then I have a separate agent from a different company, kind of like audit, start with the prompt, see all the artifacts, see the statements and the whatever the findings, and do a hard audit on every single number somehow. That seems to be working really well. I mean, at the end of the day, I still have to look at the numbers and sort of do a sniff test, like, do these look reasonable or not, right? So I do believe that the verification capabilities of models will become even better than they are now. And we can even assume that there will be a future where they will be perfect, in the sense of like, you can totally trust what the agent gives you. But verification is not only for the final sort of like result, but also in the, towards the path of the agent to solve a research question. The agent makes mini decisions, right? So let's say that you want to do something. One of the projects that I was doing, for example, one of the early sort of research vignettes that got a little bit of traction was the leaderboard, which is basically trying to figure out what is the smallest possible transformer that can add 10-digit numbers. And this sort of started with a question I had for many years. I've been working on arithmetic and transformers for many years, trying to understand what does it take to train a small language model to basically understand, if you will, how to add numbers. And although it sounds like a trivial question, it actually is not trivial at all. A lot of people have been working on it for many years. And it's sort of like a very clean laboratory or microcosm for studying how do language models learn compositional, if you will, algorithms. And so for many years, my group and many other groups have been training transformers that were like, 1 million parameters to add 5-digit numbers. And I was really curious how first of all, is that like, why are we all stuck with these big models, and why not try something smaller? So this was one of the first questions I asked to both Claude Code and Codex, to kind of like, try to figure out if we can train or hand code or whatever the smallest possible transformer that can add 10-digit numbers. And so my experience was that while I was watching the agents do their thing, I could see sometimes they could go to sort of like directions that I thought would not lead to something, or I would see them being stuck and I would be like, how about you try this, right? So I feel sort of like this infusion of agent human kind of like research it requires you to be a good verifier of like, is this the right sort of like direction or not? And this kind of like verification is not the hardcore verification of like, is the final result correct? But it's more like a feeling or an intuition that like, I don't think this is the right, I feel like there's a faster way. And somehow, so here's maybe a way to think about this as an optimization problem. So you have like, you want to arrive, so Claude Code or Codex are effectively doing gradient descent in the space of ideas and the space of experimental settings, if you will. And then there is an optimum at some point. And what humans are, a role that we can play is act as really good initializers. Like, I think this is where we should start. I think, this is kind of like the path of least friction. This is where I think the solution lies. And while the gradient descent is happening, you can also like, push the agent on one direction or the other. So I think verification can be perfect at some point at the outcome level, and I think models will become and agents will become better at making the right decision, but they still have a particular research groove, and it is different between Codex and Claude Code. And I think there is quite a lot of value still in humans navigating and steering the models towards one direction or the other. I think at the end of the day, also there's a valid question. Like, let's say all of that is completely automated. and there's a separate universe where agents are doing their own research and sort of like discovering things. What is kind of like the point of all that? Like someone has to read what they're doing and infer how does, this whole thing update our mental model of machine learning, mathematics, whatever, right? So at the very least, if everything is outsourced, we would still have to connect the dots and figure out what exactly do these artifacts mean for humanity's understanding of the universe.
So I have a question for you about how what techniques you know of to kind of promote diversity in agentic outputs. I ask this because when you talk about, the space of all possible ideas you want to work on being very large and, doing gradient descent on ideas, I really worry that reality is abundant, meaning that the space of all possible things we could be doing is so enormous it's like unquantifiable. And beyond that, we know LLMs have serious slop profiles, such as overusage of the em dash semicolons, phrases of the form "it's not X, it's Y." I'm sure that there's similar slop patterns that exist with code generation or even research ideation. And furthermore, you mentioned things like high temperature research, which is a phrase that I find particularly, compelling as somebody that works in LLM sampling designed to enable high temperature LLM outputs. But what I'm worried about is that all of these control mechanisms, for example, the temperature parameter, but also even, access in foundation models to applying, LoRa's or other steering techniques, not only are none of these supported, but what little support we did get has been, systemically stripped out, where, even access to things like constraint generation and prefix filling have also been removed in later versions of Opus. So like, what techniques do you know of or have or even want, maybe if you can't access them, for improving the diversity of the outputs so that way you can hopefully get more ideas that you would have been otherwise totally inaccessible in the vast and infinite latent space of ideas?
Yeah, that is a very good question. And I want to sort of like, take apart two components. So the first component that you mentioned is sort of like the mannerisms, like the M dashes and it's X, it's now Y. I feel like that's sort of like a surface level effect, and it's not so much related to kind of like how diverse the ideas that the models are working on, the measure of diversity of ideas the models can generate. In many ways, I feel, so here's how kind of like I perceive perhaps agents and language models. I still feel I'm the initializer. I'm X0 somehow in the optimization trajectory. And what the agent attempts to do is extract as much perplexity as possible from my sort of like initial prompt. So in many ways, I feel that the initial kind of like, directions that you give the model to will guide it towards whatever principal components of ideas that initial prompt sort of generated. So a source of diversity can be human inputs, and also using multiple agents from multiple companies and in multiple harnesses. I've seen many times Codex and Claude Code. I think it really is, like, for me, it is very useful to think of them as sort of different entities, different researchers, different sort of like, agents, because they do follow different research patterns. And of course, the diversity profile now is only limited to 2 agents, but you can increase it perhaps by using different or a larger number of models. But I do feel that you are onto something. Like, it is true that the space of ideas is infinite. And in some ways, humanity is also doing random search on ideas as well, right? And maybe we are bottlenecked a little bit by the diversity of human thought of all of these ideas. But I think it's a good question. I don't think I have a rich enough mental model to give you a good answer. But I do. So one thing I've experienced is that in some way, the richness and sharpness of ideas that comes from the current generation of models is much better than the ones before. So there is, to me, there is an intuitive improvement, or I've experienced a measurable improvement in the diversity of ideas that come with new generation of models and perhaps bigger models as well. To what extent this is capped by the number of parameters and the training flops spent on those models, I don't know what the relation is between that and, again, the diversity of ideas produced by them. But I think you're making a good point. I think it is a real quantity that we don't understand quite well, and it does feel that it is limited right now.
And I just have one quick follow-up on this. I feel bad. I'm trying to find this paper I'm referencing. I think Ethan Mollick, of all people, must have posted it on LinkedIn, where it was a recent paper, it might still be under review, about analyzing the kinds of stories that LLMs generate when you do LLM story generation. And looking to see, it's like, okay, well, we understand syntactic slop, like it's not X, it's Y, but what kind of like more semantic style slop or repetitive overused patterns do we detect? And apparently pretty much all plots are like hyperlinear with LLM story generation. They really don't like postmodernist storytelling like what Quentin Tarantino or others do, where they do, start with near the end and kind of mess with temporal. And they have all these other tendencies that they've noticed in some cases in over 80% of all stories that are generated. And mind you, I'm also somebody that's trying to put a lot of AI agentic systems into science right now with my own Claude Code and Codex, but I'm always terrified that I've basically templatized all of my artifacts in ways that I don't understand, like that there's some underlying template in the instruction fine-tuning data set that I'm really just sort of circling the drain of, rather than getting my model into even, and maybe it's just a prompting problem, but like I really worry that we feel like the diversity might have gone up, but like, how do you feel like we can confidently say that with any degree of certainty?
I think that one thing I can confidently tell you is how many and how broad, like the number and breadth of ideas I've worked on since I started using agents in comparison to a year ago. And the source of diversity is myself. So I can't quantify what I feel as very different. Now, if we were in a vacuum and the only prompt was come up with cool ideas and prove stuff about it or run experiments to validate it, I have no idea what would happen. And I would, in fact, also expect there will be some collapse of there's like these 5 things that, agents converts. I actually did a cute experiment a little bit related to that, which is I call it when Claudes meet or whatever. Anyways, so that was again early February, where basically I had 2 instantiations of Claude Code, to which I said, and literally this is just, you open 2 terminals and then you do Claude no permissions or whatever, and then you tell both models the same thing. There are 2 of you that are living in the same file system. Figure out a way to find each other and do something cool. And that was basically the instruction. And so I only ran this experiment twice, so it's very anecdotal. But in one case, what they did is they came up with a communication protocol. So they basically are like, okay, let's develop a programming language through which agents can talk to each other. So they did this within, I don't know, like 5 minutes. They developed a new programming abstraction, and then they tested and it was correct or whatever. And then the experiment sort of died there. The other pair of Claude codes basically started playing Battleship, and they created an encryption protocol, so they are not able to see each other's sort of like moves and whatnot. But I thought that was really cool as well. They wrote a whole sort of report of what they did. And then I repeated this experiment with 10 Claude codes separately, and I asked them to do something cool, and they wrote a paper about grokking. Now, all of that is sampled from
true?
some... Huh?
Is it was like a good paper?
The paper was legitimate, but the funny thing is, because I ran all 10 Claude codes on my laptop, they all started trying to run experiments at the same time, and they figured out that basically only one can run a very small experiment. So basically everybody was like, okay, you do the writing, you do the bibliography, you run the experiments. It was kind of cool. But if you were to keep running this experiment, I think it's interesting to see what would happen. So this is like, again, the idea of you're in a vacuum and you let the agents do something. And I'm pretty sure that sort of like the measure of, or the breadth of things they will work on, it's going to be limited, right? But then the question is also, if you repeated the same experiment with humans, like how would the 2 compare, right? So I think there's an interesting experiment there that someone should do at some point, that could potentially answer part of your question, but I think there is also there's a few more aspects to richness of solutions and diversity of solutions, which is basically the more multi-agents you have interacting with each other, I think that increases richness, and also the environment in which the models live also increases richness. So what I mean by that is, in a single turn type of a thing, like, tell me a story, you will see a very different behavior and very different trajectory in comparison to saying, you live in a very complex file system, do cool stuff, right? And that file system may, or that sandbox may have a CPU and you can run experiments and may have internet. So basically, what I want to say is that like every single one of those settings will basically give a different answer to how diverse the trajectories and the artifacts that the models generate, how diverse they are or how interesting they are. And I don't have a good understanding, but I do feel that the agentic setting adds a different dimension to it, which is again, the ability of multiple models and agents talking to each other and the richness of sandbox or environment that they live in.
And so, but do you think like we can get it with one agent? Do you think like we actually like there is some fundamental and principle that we need multi-agent system?
That's a great question. Yeah. Sorry, continue.
I just saw, I think, I don't remember the paper, but like I think from someone at Stanford that looks on like the single versus multi-agent systems. And they control the compute, the amount of compute. So, and they look on some different tasks. And they have some like information theory arguments, but at the end, empirically, you see, or like at least that's what they showed, that like if you control the compute, actually there is no like any benefit from using multi-agent, right? Do you agree with that, or do you think we need somehow like to construct it in a way that that the benefits of a multi-agent system will emerge?
Yeah, I will try to approach this question from, kind of like there's 2 points of view, perhaps. So one point of view is, as far as we know, let's say models up to the generation of Opus 4.6 and maybe even GPT 5.4. And again, I can't say this with any confidence. Just my conjecture is that they have not been trained to act in a multi-agent, multi-communication system. So by that, what I mean is, yes, a lot of those agents will launch sub-agents to do stuff as tools, but I have not personally seen them work extremely well when you say, there's 10 of you and you're all equal, figure out what to do. That's a bit of a different task. Now, that adds a caveat, meaning that maybe the reason why agents are not great at multi-agent stuff is because they're not yet trained to solve these tasks. Let's put that caveat on the side and also think about the types of tasks where multi-agent type of systems would be beneficial. There are some tasks that are inherently serial, right? So, for example, a lot of there's this really nice benchmark that I'm a big fan of, Terminal Bench, that effectively tests how good models, how successful they are at completing computer tasks. So you basically hand them a sandbox, you put them in a terminal, and you just ask them to do something. A lot of those terminal bench tasks are sort of like inherently serial, I would say. We've actually tried a few experiments. Again, this is anecdotal. This is not a scientific statement, but we've seen that a lot of terminal bench tasks are not parallelizable. However, you can start thinking about what are tasks that are parallelizable. And I think one really cool and impactful domain is auto research. So, for example, let's say that I would like to improve, I don't know, like the pre-training and post-training pipeline for a given model, right? And I'm allowed to do a lot of things. I'm allowed to change the architecture. I'm allowed to change the algorithm. I'm allowed to change the data. I can do whatever I want. Now, I would be very insufficient. Like a single Claude code would be very sufficient to do that. Having multiple agents trying multiple things at the same time probably would be much better. And I think there's an aspect here which is very interesting. It's not just parallelizing the task, but also having, agent 1 tells agent 10, you know what? I found that, if you were to use this optimizer, things are much faster. Use that optimizer in all of your runs. And agent 14 tells agent 2 or whatever, or everybody else, that this is the right data mixture and we can build on that, right? So basically in a more research setting, it seems that multi-agent systems could potentially do much better than a single agent or like multiple instantiations of non-communicating agents. Again, this is something that we're actively researching right now. I don't have a strong sort of opinion on this, but I do have, my intuition tells me that this is sort of the right setting where multi-agent systems and interesting communication protocols will emerge. And perhaps this, my conjecture again is that we will see an advance in multi-agent systems in the next 6 months related to automating R&D.
So you mentioned auto research, and I think it's very interesting topic because, like, at least from the recent papers that I saw, it's called the inference bench, I think, and the FPM L bench, something like that. If like for our audience, if you don't know, so like the idea is that you have like a very specific task and you let the agent to improve some like other model. Basically it had like access to the code, to the hyperparameters, and the idea that you want to improve the like this like the other model, you want to improve it on some downstream task, and you let your agent to change all the different parts of this model. And it looks at least from these papers, it looks that it doesn't really work. That like if you compare to like, I don't know, Bayesian optimization or like different other methods, it doesn't really improve the result. Like it kind of like find a bit better hyperparameters maybe, and maybe like, explore here and there, but it doesn't have very fundamental changes, right? What's your thoughts about it? Do you agree, or do you think like we don't have the right settings, or like it's something that I don't know, it should get better?
I think, will it get better? I think the answer is yes. On like every time the question is, will the models agents get better? Yes, they will. But the current generation, I think you are right that. So here's the problem, right? There are settings where the problem is too hard and agents won't do better than humans. There are settings where the problem is very easy and they can do as good as humans because the ceiling is already very, very well known and you can break through the ceiling. And there's sort of like problems in the middle where humans may be still better than agents, but there's a big chunk of the task that's extremely boring and intensive, and you would like to outsource that. So what I mean by that, so I'll go back to the sort of finding the smallest transformer. Could the student do the same thing as Claude Code and Codex? Basically, go from 1 million to, let's say, 1,000 parameter transformer? Definitely. As evident from the fact that once I created the leaderboard, soon there were sort of entries and solutions that were like, the smallest was like 6 parameter, a 6 parameter transformer. But here's something that's really cool. So the model did not arrive at that 6 parameter transformer. The model did much better than what we tried to do 2 years ago. And also the fact that I woke up one day, I had the agents run it, we arrived at something smaller, then I passed it to the community. And I'm like, we know that a small one exists, let's make it better. This, in fact, ended up accelerating the search for a smaller transformer, right? So I feel like there was this chunk of middle work where, going from 1 million parameter transformer to like, 1,000 parameter was completely automated, and it was automated really fast. I think that's the other thing that's kind of it was very surprising to me. It literally took one afternoon. It did not take, a full week of hyperparameter search or architecture search, right? And this acted as a seed to the community to say, well, let's look at the solutions of what the models came out. Let's try to optimize them, right? Yeah, I don't have the counterfactual to know how much longer it would take in the absence of sort of like, the agent solution. But I do know that for many years, we kind of like, either because we didn't care too much about it or because we didn't work hard enough, we were stuck around, I don't know, 1 million parameters, right? So I feel like rather than thinking about this as a unit test, can the model do better than humans? I think maybe the right question is, to what extent is it actually accelerating research? And for the models and the agents to accelerate research, you have to put them there's this process, right, by which you build the experiment and you tweak the numbers or your hyperparameters, and you extract insights and whatnot. And there's components or chunks of the pipeline that now can be completely automated. It does not mean that the model or the agent is doing end-to-end research, although it is very close doing that in some domains. But it does mean that it can accelerate it significantly.
And
so I wanted to ask something. You mentioned a lot earlier too about your GSM 8K results, where you're getting like 10 or 11% with basically if-else statements. I'm very curious about the performance of decision trees or random forests, which are basically just lots of if-else statements. And in particular, the importance of things like featureization around like how you represented the GSM 8K questions and the answers. Like, was it tokenized similarly to standard LLMs?
Yeah, so this is actually an experiment that I dropped early on because the agent stuck, and I restarted yesterday. And I can so that's good because I'm sort of reminded a little bit of the process and sort of what the models did. So the instruction was basically study the trained data and look at the patterns of the trained data and effectively create an extractor of like a question to a program, right? So like if the question is Mary has 8 apples and George has twice as many, and he gives half of them to, I don't know, Elizabeth, how many apples or eggs or whatever they had are there left in, whatever, George's backpack or whatever. So taking that statement or that question, you can transform it into a set of questions, right? Or like a set of, I don't know, Python lines of code that then you could paste in an interpreter, and then you could get the answer. So the hard part with GSM-8K is mapping from question to a program. Solving the program, if you have a tool, is easy, right? So, and then I assume tool access is fine. You can have a calculator. In many cases, for smaller models, learning arithmetic is pretty hard. And perhaps I thought, I don't have a decisive answer yet, doing the question to program map may be somehow doable with sort of the symbolic way of extracting stuff. And so what both Codex and Claude Code did is that they said, well, let's pattern match first and create a set of principal programs, basically a set of programs that if you had them, you could map each question to one of those programs. And then it came, that came down to something like, I think there's like 7,000 questions in the train set of GSM-8K. And then it boiled down to, let's say, I don't remember the exact number, 500 programs. So then that list of 500 programs, let's say, covers 80% of the training data. And the question now is, how do you rank? So now you kind of want to rank these programs and sort of pick the one that you think is the best one. And in none of that should you use a language model whatsoever. So then it becomes a question of like, finding the right, pattern matching to the right program. And unfortunately, that tends to be a little bit hard when you are only based on sort of like grammar and syntax semantics. So that's why, it was stuck at 10%. And then I was like, maybe it's a classification problem. So what if you were to build a classifier? So it's like, question with some features and then program, right? So which program to pick is a classifier of like, this is, out of the 200 programs, pick that one. And so perhaps I'm like, maybe I allow you to train a small model. And that also did not work very well. So back to your question about, what was it, XGBoost? I don't know, but I'll ask Claude to try XGBoost as well. GSM-8K turns out to be pretty tricky. Yeah. In fact, I mean, I can even, since you asked, let me check the progress now, if we have any progress on that.
You can ask online, you can ask Claude if
yes.
it has
because it's running in the background. I've resumed yesterday. We'll find out. So I asked, I'll go back to the tab and tell you in a second. But we were stuck around 10%. So it is hard. Yeah, I don't have. Claude keeps insisting that I said you have to beat 50%, and it keeps pushing back that there's no way with symbolic to go to 50%. So current test accuracy 11.5%. So it's climbing. I actually have, with auto research, this cool thing, which is basically accuracy versus number of ideas, and it's slowly crawling up, and we went from, I don't know, 4 to 11.5%. And by the way, random guessing is pretty bad because the answers are numerical. So I think random guessing is probably like less than, I don't know, like 0.1%, let's say, something like that. So 10 or 11% is higher than Llama 1.7b. All right. So a symbolic method can be better than a Llama model, but we don't know. My hope was to get to GPT 3.5. I think had 40%. So I would like to claim that the symbolic model can be better than GPT 3 at GSM-8K, but I don't know if that's true. So anyway, I'll let you know whenever the result comes out.
But there is like this type of auto research. There is also like, and also in continual learning, there is type of like kind of like, I don't know, overfitting or something like that, right? Like you ask the model and it summarizes something, and then you can have some decision tree that like based on this like past experience, right? Like and I feel it's like you need to be very careful, right? It's like, right, like now you have questions, bunch of questions, so of course you can find some set or like some like split of questions that you can actually like walk in this tree, right? What you thought about it? Do you feel it like we need like better analysis or like better tools to actually like to prevent from overfitting, or like at the end, as we see now, that like, yeah, that's fine, like everything like we will solve it, or like everything that we are solving because we have so much data and these like models are so powerful that we feel like we will align them to the right direction. We don't care about overfitting.
Yeah, I guess I never quite understood the definition of overfitting, to be frank with you. So there's overfitting on the training data side, like, make your error 0 or whatever. There's overfitting on the test side, I suppose, and there's idea overfitting. I guess I have opinions about all of them, but I think on the idea overfit, I think the idea overfitting is the most interesting thing. And I would, instead of calling it idea overfitting, I would say agents are very insistent on one approach. So when they've spent 1 million tokens doing one thing, at least my experience with both Claude Code and Codex, it's so hard. You tell them, try this other thing, and they will come back to whatever they've been doing. And the only solution to that is to restart the session in the hopes that this won't happen. So that is pretty interesting, that there's this weird sharpening that happens, and lack of diversity, in fact, as the more they work on a problem. So yeah. But I don't know if that's the kind of overfitting you're thinking though about, or if it's
So
more about
I'm
the actual.
thinking about like, no, I'm thinking about like, I don't know, you have some data sets with questions, right? And now you have like, you run some, like you ask your model to design another model that will solve it, right?
Yes.
And then you ask it, okay, look on these, like on the types of like error that you are doing and fix them. Right?
Yes.
And like, and you will have kind of like a lot of, I don't know, if else at the end, right? That like, because the model is so powerful, it can understand, okay, so if I have this type of questions, I will do something like that. If I have this type of question, I will do something like that. And now when you have an agent, like it can do basically like, it can like do like to solve for each, like really like fine types of questions, it can solve it like completely. The question, do you think this is like at the end the right approach, or like we need to put some, you can call it like regularizers that actually like prevent it from fit very like specific types of questions?
Are we talking about GSM-8K in particular, or more generally about research questions?
Both.
I mean, yes. So I guess the short answer is that yes, the model will like, if you indeed build that weird system with if then else, it will probably be quite brittle, I would expect. What a regularizer would look like, I'm not so certain. I also want to caveat that, I don't know whether the GSM-8K experiment is interesting or useful at all. It's interesting to me, and that is why agents are spending time on it and not me. This comes back to this sort of ability now to do stuff that you typically would completely ignore, which is kind of cool.
But I mean, like more in general, like let's assume that like, right, like we have tasks and the agent need to use some tools in order to solve it. Okay, so we have some questions or whatever. And now, of course, the agent, like you can run these questions, and the agent will use some tools, and now you can take it and you can let the agent analyze these traces, right? You can let them, okay, so, and now it will come up with a list of failure cases, for example, that now I use this tool instead of this tool, or I use this tool in the wrong situation or whatever. And then it can come like with a list of failures and how to fix them. And now you
Yes.
run it again, and probably it will work out, right? It will fix these failures,
Yes.
and you can do it again and again and again. And I feel it like a lot of problems that are, or a lot of solutions that people are trying are kind of like fit to this scheme. Do you think this is the right approach, both in general and also for research?
Yeah, I think so. I will sort of ground this in a particular setting that I've seen this happen quite a lot, where people are trying to create agentic harnesses
Yeah.
for model, or optimize harnesses for terminal bench. So what does and they try to do this in sort of like this meta harness way. There was this really cool paper called I think meta harness optimization, and also a lot of other work that tries to do something similar. I give you a task, an agentic task. I have unit tests for it. I know sort of like what I know what the agent does. I collect all the trajectories, as you said. And then I have Claude Code or Codex look at the trajectories and say, make the harness better so that the model does not fail at those tasks. So what will happen is exactly what you said. If the models are completely unhinged and no sort of like, regularization, even verbal regularization is in place, they will actually try to, like, sometimes they will even infuse the solution itself inside the harness. In fact, there was a terminal bench entry that I don't know how it was designed. I don't remember who, I remember the group that created it, but they were basically scoring, it was like the top entry. And people soon figured out that somehow the solutions were part of the harness somehow. And so that's an extreme case, of course, and I don't know exactly the intent for why you would create a harness like that. But even if your intent is to sort of say, well, here's like some common failure cases, try to avoid them. I think the problem is that these failure cases are exactly very particular to the problem that you're trying to solve. So I think the question that perhaps we come back to is, how do you build harnesses and whatnot, and frameworks, if you will. A harness is like a framework or a scaffold for a model to solve a problem. Like that thing should not overfit to the setting that you're trying to design. The task that you're trying to solve, because it will be brittle. And so, what is the most general purpose thing you can come up with? There's no harness; it's just a for loop over the model, right? But the problem is that this would only work if the model is extremely capable. So because of lack of extreme capability, then you start patching, if you will, and augmenting the harness with tools. That's fine. But also you can augment it with system messages that say, try to do this, try to not do that. I've seen you fail many times on this task, try to blah, 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 right? And sort of this is patchwork because of the fact that, there are still, the models are very spiky in their capabilities. And they can also be pushed in sort of like directions that maybe they're not very well at yet. But an artifact of that is that there is quite a lot of patching that is needed on the harnesses for those agents. And also part of the reason why, they may be brittle if you try to push them a little bit outside of their comfort zone.
But this is something that, like, at the end, it's a thin line, because like you also, even if you have like very powerful model, you wanted it to learn from experience, right? Like kind of like
Yes.
memory, right? Like from past
Yep.
trajectories, right?
Yep.
Like continual learning. We want something like that.
Yes. Agree.
So do you think there is like, how do you see the solution?
Yeah, so I think continual learning is vastly unsolved, not necessarily because we don't have the right ingredients, but perhaps because they have not been fully clicked in and dialed in. I think there's two components to continual learning. One is collecting textual experiences, like literally in written text, sort of structuring them in the right way. So what I mean by that is you can have memory files, or a single memory file, or a file system of memory files. And it seems to me that right now we don't quite know what should work better, but it seems to be the case that organizing memories as a file system is a very meaningful abstraction and part of the answer to continual learning. But somehow continual learning is not just storing new experiences in a text file where you can like look back, because obviously that text file will keep on growing. And maybe a single text file is all you need for a single task, but you want your model to learn from every task that they, every task that they try to solve, but also every interaction with the environment that they're trying to have. So our sort of answer to the second, like how does a model learn from its environment, is to basically put the model in a framework of acting as a world model for its environment. So what I mean by that is you can actually, for computer use agents or for terminal-based agents, every time you act in your environment, you see that the environment's response to your action. So that's actually really good training data that you could use in the model to basically make it a better speculator of what will happen as a reaction to its own actions. And, hypothetically, by doing that, the model will have a better prior on the right actions as well. So we actually have a paper called Echo on this, which basically does exactly this idea or implements this idea in the context of terminal agents. And we see that basically trying to learning how to predict your environment makes you a better policy. RL becomes faster, more sample efficient. You also are able to unlock continual learning in the sense of you can switch off RL completely. And the only thing you do is basically you have a model, just play with its sandbox. And you give the task and then it does a bunch of stuff. And the only thing it has to do as part of its continual learning is to try to predict what the environment would do. And then when you look back at the accuracy of that model on held out tasks, the accuracy increases as a function of like how much world modeling you try to infuse in that model. And sort of like what I'm trying to say is that basically, I think a key component of what you said about, memory and continual learning is to sort of like, keep evolving as your environment changes or as your environment reacts to your actions. And I've been thinking quite a lot about this in the context of users. I've been using GPT and Claude for, I don't know, since ChatGPT was, or since GPT-3 was in fact in the playground. And I feel how awesome would it be if they actually, and by they I mean, OpenAI and Anthropic, if they trained on my own outputs, it would be so awesome. I would love a model that is adapted to me. I would be totally fine to give them like, take all my history from both, from both worlds, from like the GPT and the OpenAI and the Claude world, and fine tune the model to predict better what I will say. And I do think that this would lead to a much more, a model that continually learns. Like right now, Claude and ChatGPT, the way they do is they have a bunch of memory files and they have some way of accessing, I suppose, past conversations, and it sort of works, but it's not fully dialed in. And I do think it would be kind of amazing to see models evolving with their user. And I don't know why this doesn't happen now. I think it's kind of like perhaps a harder thing to test and get signal of whether the user actually prefers the attuned model to its to its long-term sort of behavior. But it's also maybe harder to serve. Like personalizing one model per user may be really hard to serve. But this could be I sort of like imagine a future where I have a language model that lives on my computer. It's a much better computer than the one I have now. And with everything that I do, the model learns much better how to predict what I would like to do and what I would like to see, perhaps. And I do think that this sort of like long-term preference may be a better signal than sort of like short-term, single-turn RLHF. But anyway, so I'm diverging a little bit, but
no, it's like in our previous work, like me and Ellen actually like tried. So like the idea was to like that you have like you have access to all your Slack messages and your emails and like all your things, and then you can personalize the model to be like you, right? To think or like to behave or like whatever like you. So yeah, there are a lot of cool things there, like how to personalize models. And it looks that it's not so difficult, I must say. And you don't need a lot of data in order to do it. So I'm also quite surprised that Anthropic and OpenAI are not doing it yet. Okay, cool. What what about so continual learning? Like at the end, what do you think the future will look like? Do you think like the future will be that like we don't need pre-training or like mid-training, post-training, and everything is continual learning and then from environment? Or do you think we'll still see these like training and then you collect some experiment and at the end you try to integrate them? It can be into the weight or like to a file system. Do you think this separation will still exist in the future?
Yeah, that's a good question. I don't know. I think it's hard to speculate, but I will say that like in some way, continual learning is happening right now because models are getting better given the data that these frontier labs are collecting. What I mean by that is, there's tons of users using Codex and Claude Code, and they create really useful data. And through the data, you can basically tell the good from bad trajectories, and you can use this as part of your post-training or RL or whatever pipeline. I don't know, if this would be called post-training or continual learning, but the fact that the models are improving and the fact that the users are finding new and exciting use cases that then feed back to the models improving is in some sense continual learning, but just the snapshots are not as frequent as we would like them. So what I mean by that is, if you meet a person for the first time, you have no mental model of how they behave, who they are, and whatnot. But within 5 minutes, your mental model is updated, and within an hour, it's updated, and within 5 days and 5 weeks and 5 years, your mental model continues to change, right? And this happens in a much more continual way than current models. And I think this probably will change at some point. So I think I do think a component that is not there yet, not because the algorithms are not there or the data is not there, but because I guess they haven't perhaps tried it yet. I don't know. I can only speculate. I don't know what's happening at those labs. But I think the component that's missing is that basically every single interaction is a useful data point that can be immediately consumed by the model to become better. And how that is enabled is an open question. And I think there's a lot of interesting infrastructure questions related to that I don't understand very well. But I am optimistic and hopeful that these questions will be soon resolved. But I do think that yes, there will still be a separation between having textual file system like memories and updates, weight updates related to whatever past experiences at the same time. And maybe the way that I would think about this, and humans sort of experience something similar. You have your sensory system is looking at all the, there's so much text and visible information or whatever that goes in your attention window and stuff that happened in the past that are still in the attention window. And there's experience that changes you because, it's useful to change with regards to, a particular experience and with regards to a particular mental model that you have of things. And these do seem to be a little bit separate. I don't have the right language perhaps to describe them. I'm not, an expert in how the human brain works, but it does feel that there are different abstraction levels of memory somehow, right? And, I can't predict or speculate how this will look for models, but if you were to tell me it's going to be some combination of having a file system of memory files plus updating, with a completion of every task and with, every once a day, with a collection of data, or once a week, the model also updates its weights. I think we probably will have both. And I can't tell or speculate to to how AGI complete or memory complete that would be, but it seems pretty reasonable that these are the two principal components of what a memory complete system would look like.
I wanted to ask a little bit about agent-to-agent communication. You'd actually brought it up earlier. And I wonder, in multi-agent systems, I think a lot of the value is the separate context windows that potentially don't get polluted as much with each other's context. And I think this is analogous to the idea of alienation from things that you don't work on, right? Like how important it is to kind of specialize for humans. Do you think then that AI, like agent communication, would look a lot like human communication, and that we should basically just look in the mirror for ways to do project management with agents? I guess what I'm trying to ask is Jira and tools like that we use for project management today with humans the right tool for management of large numbers of agents? And if not, what do you think is the difference?
Yes, good question. I think the answer is probably not, but whatever management systems we have and whatever communication systems we have right now for humans can act as a good starting point for agents as well. And the reason is because you can actually create data for those things. So let's say, the simplest of things. Let's say one silly way of having agents communicate with each other is that they share a Slack channel, right? Or a simplified version of that is like a text file with timestamps, right? So you could start with that as the most basic communication protocol, and maybe there's like a shared GitHub work tree or whatever, I don't know, and see how that will evolve, let's say, with reinforcement learning. There is something useful about words, and whatever tokens that mean something, which is that we can create data from it, and it's the native way that we speak, and it's very interpretable, and it is the way that models speak right now. But I also think that it seems pretty wasteful when it comes to agent to agent type of communication. Like, why do agents have to token? Yeah, again, it's good that it is interpretable, but if we think about efficiency and performance and I don't know, some downstream accuracy, it seems more reasonable to perhaps token soft tokens or connect the activations or their brains with each other, right? Now, how do you arrive at something that is at that type of a communication protocol? I don't know, but I suspect that the jumping board is human language, and it is a system, and it is a communication system and a communication protocol and a task management type of a system that is very close to what we're using right now. But I do feel, or I do expect, that if you do a lot of reinforcement learning, a lot of outcome-based reinforcement learning, and sort of relieve the models from the burden of talking in tokens, we may see something pretty interesting. So yeah, my speculation is that because of the fact we can collect data over what protocols we have, they probably will be the starting point for how models communicate and manage projects. But I don't think that that's necessarily the most effective way of models communicating with each other and managing, really big projects that are very heterogeneous, and subtasks can emerge for different subsets of agents. And yeah, I think it's hard to speculate, but I do think it is a very cool problem to work on. And in my group, we're actually thinking about communication protocols. Actually, an intern that we have right now at MSR is thinking about this question this summer. So,
what do you think about multimodality? Because till now we talked about coding agents, right? Then they're talking with text, and they're writing and reading text. Do you think the future, the most appealing direction is to push it to vision, right? It, like the agent can, I don't know, communicate with some vision tools or something like that? Or do you think we should push we should push it inside the model, right? It's like everything, some unified representation, vision, text, audio, whatever.
yeah, that's a good question. I feel like I have a couple of opinions on that. First of all, I mean, as humans, it's kind of awesome that we are multimodal in some sense, right? So there's there's text, there's voice, there's there's all the senses that we have. It's pretty awesome. And they're integrated in a way that I don't understand in our brain. It seems to be much harder to do this with models, meaning that, current multimodal models seem a little bit, you try to force, there's images and then you have to put them in tokens, and maybe there's a separate module, or perhaps this, all the heads of the transformer are trying to process everything at the same time. And it's not exactly clear. I mean, this seems to work pretty well for some tasks, but I do feel in terms of solving hard tasks, let me back. It's solving hard digital tasks, AI research, let's say. Do we need a multimodal agent? And it does seem to me that you need vision, but perhaps you need vision as a tool. So what I mean by that is, what if I had, there's an incredible text model that has no vision component, and I have a vision model that is really good at describing a particular image. Could that be enough? Perhaps. I'm not sure. But I also it's hard for me to think of problems that require vision to solve, if you try to sort of decompose or look at the principal components of AI research, I mean, we obviously use a lot of vision, right? But you can describe a lot of them without using vision. And yes, you will, at some point you will have a PDF where you have to parse you have to parse a figure, or you have to parse, I don't know what, right? But in many cases, figures are artifacts to communicate an idea. But the elements of that idea can perhaps be sort of packed into language as well. This is not true for things that are generate images and generate video. This is a completely different thing. I'm just trying to think of if I want to work on a paper that would be presented at NeurIPS or ICML, do I need, and I'm an agent, do I need vision as a tool, or do I need vision as a different modality? And it feels to me and I don't want to be sort of, I want to sound certain about this, but it does seem to me that you can be AGI complete, if you will, with an extremely good terminal agent and vision as a tool.
And do you think this is also true for like embodied AI, physical AI, this?
I think that's a good question. So first of all, I would think of terminal agents as embodied. It's just their environment is not physical; it's digital, right? So you have a digital somehow, like they interact with an environment, which is very cool. But you are right that when let's say 10 years from now, I don't know if it's that, but let's speculate and a number of years from now, we have we have robots, and robots have the brain of GPT-7 and Opus 6.4 or whatever. I mean, they will have to be multimodal, right? I mean, I don't know to the extent. At that point, it sounds hacky to have like, I don't know, a vision model describing what you see and a sounding model describing what it hears. It sounds like there has to be some solution that's much more uniform, only because generality seems to be at the core. It's a core principle of these models working very well at really difficult things, right? So how will these multimodals be trained and what the architecture will look like? It's hard to speculate, but I do feel that in the real embodied setting of like a robot and a digital brain, it seems like multimodal models would be required.
Okay, we almost need to finish. I just want to talk with you about information theory and AI. Like we had a recent discussion on Twitter. So like both of us have like kind of like information theory background, and the main question every time that I'm working on things that's related is like how like can we describe or like can information theory be helpful in AI and like in AI research and like better models, like better explanations. So what's your thoughts about it?
Yeah, I think, first of all, information theory is, an incredible area of research that has, it started with Claude Shannon, and the fact that we can talk on this screen today, we can actually attribute to information and coding theory. The fact that there's reliable storage of bits and reliable communication of bits. This happened because of information theory and probably could not have happened without information theory. I do think, however, that the success of information theory in storing, recovering, and transmitting bits sometimes makes people overeager to think that it can answer everything, right? So it can be used as a tool to uncover deeper truths, and sometimes this is true, but a lot of times it's not true. So I've seen many times work that attempts to sort of solve information theory in every aspect of understanding something. But information theory is typically not a good tool to understand algorithmic and sort of like statistical learning, if you will, or, AI phenomena, right? There are cases where it is very useful. I think that, we had this very useful interaction and discussion with Andrew Gordon Wilson, who's a professor at NYU, about epiplexity, which is a very cool way of understanding sort of like, limits of learning when there is also sort of a computational complexity lens attached to entropy. But I think that the bigger caveat is that sometimes, we like tools, and sometimes we like tools because they may look cool, or because they may look deep, or because they may have answered questions. Doesn't matter why we like them, but sometimes we like them so much that we want to use them everywhere, right? And the analogy I gave is like, so if you try to explain all the depths and mysteries of AI with information theory, it's like trying to make pour over coffee with a Japanese katana sword, right? It's a great instrument, but maybe this is not the right task for it. And I do feel that like sometimes, and I found myself, trying to explain things with the one tool that I'm very familiar with and I like a lot, and it's not the right approach. So I think sometimes we just have to be, it's hard to not be attached to your sort of like beliefs, right? But when we work in an area with so many mysteries, I think we have to be a little bit untethered from this sort of like, tendencies to use the tools that we know work. And, as an example, so I also started as an information, or I should say coding theorist. And we've worked with my advisor, Alex Demakis, on coding theory for distributed storage. And it felt at some point that this problem was solved. And then we started working on more algorithmic problems. And I slowly walked my path towards machine learning. And I've always tried to infuse a little bit of coding theory and information theory in my thinking. But I think that the biggest lesson that I've learned is adaptability is an incredible skill. And sometimes adaptability implies dropping and softening my tendencies of using the tools I'm comfortable with on a new topic. But at the same time, having sort of like, this broad, I don't want to say deep understanding, but it is a broad understanding of like, starting from wireless communications and then information theory and coding theory and I don't know, algorithms for graphs and optimization and now language models has made my sort of mental model of, grappling with language models much more accurate. So did information theory help me understand language models better? Yes, but not in a tangible way. I can't say, I could not have understood that aspect, but it has for sure sharpened my ability to deal with, with my hypothesis and with the mysteries that, LLMs are.
Yeah, I agree. I think you said it like really nicely. It's exactly also my perspective. I think that at the end, information theory, Shannon didn't build it for learning,
Yes.
and you are not in a world that you actually need to learn something. And I think this is the main bottleneck or like the biggest problem with information theory. And I also agree at the end, like in the sense that like you can't be constrained by your beliefs. And I think like the greatest researchers, they really want to understand something, but they don't care, like they're willing to change their mind if they see something that actually changed their beliefs, if they see an evidence that changed their beliefs. And this is like one of their like biggest the thing that actually make them such a good researchers. Okay, I think we out of time. Do you have something that you want to add, that you want to advertise? Are you hiring?
I mean, yeah, we are always hiring. But I think that what I would like to maybe end with is that it does feel like a golden age of asking questions, and I feel it's sort of like, maybe the thought to live with is we should start asking bigger questions, because I do feel in many ways we're much more sort of like bottlenecked by our tendencies and whatnot. But I feel like a lot of the technical constraints have now been lifted. So it's an incredible, there's a lot of dread about, AI research perhaps and mathematics and whatnot, but I do think it's an incredible time to do research now. And there's quite a lot of value, I think, still to the human factor, because research is not just, doing the math or like setting up code, but, it is connecting the dots and communicating things and understanding things and communicating that understanding. And also at the end of the day, developing good taste and asking really good questions. So I think we're at an inflection point, and I do think research is much more exciting than it used to be, and a lot more fun. So, I guess I just want to end with have a lot more fun. It's a great time to be alive. So, yeah.
It's a great message. I agree.
I too agree.
Dimitris, thank you so much for coming. It was a pleasure to have you.
Thank you, guys. This was awesome.
And bye, everyone.
See ya. Bye-bye.